All right, everybody. I'm going to begin, and as people shuffle in, I'll just tell you, for starters, that you are in listen-only mode now. And if you have audio issues, two things. One is try connecting through your phone. If that doesn't work, send us a chat, and you can chat just the panelists, and we'll try to debug it. But we're going to do all the questions and answers in the chat box. I just want you to be aware of that. So everybody, as you get settled here, first housekeeping item. Can you, if you do not already have this, edit your name in Zoom? So you go up here to your picture and you click on those three dots and go down to the thing that says rename, and you can type in your first name, your last name, and your affiliation, like that. See, so you can, I said Peter Fist, NAWI. That's really helpful, so we all know who everybody is, and this is what's nice, is that once we have everybody's names, everybody can see each other. So thank you very much for doing that. I see a couple of you still doing that. Great. The second thing is, as I said, we love chat here at NAWI. Feel free not just to chat, but when you chat, if you're addressing me or a particular person, maybe somebody else has asked a question, use their @first name, and feel free also to send the chat to everybody so we can all see what everybody else is saying. If you would like to share links, maybe about your technology, maybe references to other pilots or demos that you're aware of, you should feel free to do that. We are going to save the chat log. We're going to post it along with a recording of this workshop. And this will all be available on NAWI's Alliance website, and we will tell you a little bit about that. So today, our agenda is going to start. We've gone through some logistics. By the way, this is being recorded, so thank you for that. I'm going to start by sharing with you NAWI's overall research mission, and in particular, why this piloting is an important part of that. I'm going to talk a little bit about what we mean by pipe parity treatment of non-traditional water sources, and why NAWI is so particularly interested in distributed desalination and distributed water reuse, which is why in particular we're interested in small scale systems. We'll talk a little bit about the research challenge areas that NAWI has defined through its road mapping process, the A' challenge areas. And then I'm going to wrap up and tell you about some of the key capabilities that has been developed by the NAWI program. These are capabilities that you might want to use as part of developing your pilot for your demo. And these include WaterTap, which is a modeling system for modeling the economics of water treatment systems, as well as unit process modeling. Water Dams, which is a data management and data repository, where we will want successful pilots to post data. And then I'll tell you a little bit about our 5 PRIMA roadmaps, et cetera. We'll then talk about the purpose of this RFI. And then we're going to turn tables. Zach and I have some questions. This is an RFI, a request for information. It is not an RFP, at least not yet, but the more help you can give us, the more advice you give us, the better we can craft this program. We'll wrap up by discussing a little bit of the what, wheres, and whens of the RFP, if and when we pull it together. So again, this is all just exploratory. We're asking questions for the water community, and we so appreciate your help. And Zach, I just say, if you monitor the chat window, you can feel free to interrupt me if somebody comes up with a question or wants to stop and address a topic right now. So thanks for that. And then finally, we'll have Q&A for as long as you want. And again, all this is recorded. So if a friend of yours misses this, hopefully they can access this recording. All right, I want to start with this. This is your hub. You know, the Department of Energy asked us to organize NAWI for the benefit of the water community. The purpose is to accelerate the development of effective, clean water solutions from non-traditional water sources at what we call pipe parity. We've done this in collaboration with the US Department of Energy's Advanced Manufacturing Office, but we also have other supporters and investors, including the California Department of Water Resources, DWR, the California State Water Resource Control Board, and EPRI, the Electric Power Research Institute. So all those entities have pooled money into the NAWI program. We do several things. We develop new tools to develop and accelerate innovation in the water sector, and that's what I kind of told you about right now. NAWI roadmaps, WaterTap, water dams. We also are funding early stage applied research projects in areas that we believe are the highest potential impact for achieving pipe parity for non-traditional water sources. And we also serve a role coordinating with other research activities, both within the Department of Energy as well as in other agencies. So we are in intimate contact with Juliana Porras Mendoza and the team at the U.S. Bureau of Reclamation. We talk to people at EPA, et cetera. So as you consider NAWI, it certainly could potentially be a supporter to help you develop your technology, but also we want to encourage you to use NAWI as a means to learn and to network. So your engagement is really what makes NAWI a success. So we encourage all of you to get engaged. And this means to understand what I call NAWI's theory of action. Now, NAWI does have a research consortium. This is the group of researchers and research institutions that are doing this research right now. And for those teams that come together and are selected to do a pilot, your organizations will join the NAWI Research Consortium. But we also have this larger organization called the NAWI Alliance. This is a no-cost membership organization where we want to draw in people from large companies, small companies, other federal agencies, state agencies, nonprofits, anybody who is interested in desalination in the water sector. We want to draw you into this membership program so that we can give you access to all our digital content, recordings of all our past webinars, all our software, and a database where you can find and network with each other. Our goal is to create a community where researchers research high impact problems and they find each other. So that's our goal. Now, you can learn more about us at our open website, which is www.nawihub.org. But you'll notice up here in the right-hand corner, join. What is this join? The Alliance is a separate website. It's a login website open to everybody who signs up and submits an application to join the Alliance. What we have on the Alliance website is a whole database of every member. So we have more than 300 organizations, more than 1,200 individuals with profiles. Think of it like a private LinkedIn for the desalination and water community. So if you aren't a member of the Alliance, we strongly suggest that you join, because we will also be posting this recording on the Alliance website, not the main website. And again, the Alliance is free, no reason for you not to join. So I hope you can do that. Now, when we approached the Department of Energy, we had a very particular thesis about where we thought desalination and water reuse needed to go. And we started with this observation that the 20th century water systems that our communities and our grandparents have built for us are wonderful and marvelous, displays of engineering innovation. But they're fundamentally linear in nature. And that is to say, they start with typically a freshwater source, sometimes very far away, and they bring that fresh water to large centralized treatment. We typically treat that water to a uniform quality, or most often drinking water quality, and then we send that drinking water out across a network of distribution pipes to a wide variety of uses, including drinking water, which is great, but also industrial use, et cetera, et cetera. As that water is used in our communities and our industries, wastewater is again brought back to centralized treatment facilities, where we then put a lot of energy back into the water to clean it, frankly, to a sufficient level to just throw it away. Okay. Now, this linear process has been how we've been operating water systems in the 20th century. And our concern at NAWI is that this 20th century linear process needs to change. And here's why. We, of course, have climate change imposing more and more stress and uncertainty on our freshwater supplies. And we are now seeing communities, particularly in the West, who cannot rely on freshwater supplies for the long term. We also have a long-standing aging infrastructure in these centralized systems. And in many places, that infrastructure is at the end of its life and is starting to break down. Today, we have communities across the United States that do not have access to safe drinking water from a pipe. They have to deal with either bottled water or localized treatment. And then finally, our industrial sectors discharge wastewater under proper permitting, but we discover new and emerging contaminants. And these new emerging contaminants can potentially impose new liabilities on our industrial sectors. So this one-way process is something that may need to change. Well, this is not new, this idea that we need to use new different sources of water. Of course, back in the 1960s, the Kennedy administration started the Office of Saline Water and started investing research and development in technologies such as reverse osmosis. And today, reverse osmosis of seawater is one example of a non-traditional water source, seawater, being processed into fresh water and being used in our communities around the world. It's an incredibly successful technology. But ocean water is not the only salty water that's out there. We have other places where we produce wastewaters and salty waters that presently we don't reprocess. For example, our power sector uses water for emissions as well as for cooling, and we create salty water in that environment. Our agricultural sector produces runoff and produces agricultural drainage water, which becomes too salty to use. And of course, naturally occurring salty water in the inland part of the United States, brackish groundwater, is an abundant resource, but often too salty to use in its current configuration. There are only a handful of places, well, not a handful, but there are more and more places in Texas and the Southwest where we're using brackish groundwater as a non-traditional water source. And then, of course, I said our industrial sector produces wastewater and consumes fresh water. And presently, they produce a lot of this wastewater and again, discharge it often at significant cost. What's interesting about these non-traditional waters is that they are geographically widespread around the United States. They sometimes even contain valuable constituents that we're throwing away. So NAWI's thesis is if we could advance the forefront of technology to economically treat these non-traditional water sources, not just ocean water, which we are doing research in, but all sorts of other non-traditional water sources. And if we could lower the levelized cost of treating that water to the point where it's at the same cost of the current marginal supply, we achieve something called pipe parity. And that is the new water source produced through desalination water reuse is at the same cost as the current marginal supply. If we could do that, we could stabilize water supplies in much of the United States and supply cost-efficient water for our communities and our industries. So that's NAWI's goal. Now, pipe parity, achieving that cost reduction for treating these non-traditional waters is only possible if we think more than just improving the unit process efficiency. We argue that you have to rethink the 20th century linear system itself. And here's our argument. Presently, water treatment technologies enjoy a very favorable economy of scale. That is to say, as you make your treatment plants bigger and bigger, the unit cost for producing clean water tends to go down. That's a favorable economy of scale. But we live on a planet with gravity. And when you have large systems, you bring water from large distance and you push water out across large distances. And because water's heavy, these large systems often have a large cost associated with just moving the water because water is heavy. And so this is why we don't have a single water treatment plant on the Lake Superior and are sending water thousands of miles to Texas, because the energy associated with conveyance would overwhelm the cost. So this is how we've gotten to today's system. We have a sort of a curve of levelized cost of water and a sort of sweet spot for current treatment plants and a current operational scale. Our thesis at NAWI is if we look at this side for small scale treatment systems, we see a big technology opportunity zone because unit costs for treatment are high, but you don't have the conveyance cost. And this is our idea. If we can innovate together with you and lower the cost of small scale desalination and reuse, we can have a much shallower and flatter treatment cost curve. That would lower our cost and our levelized cost of water, but it would also shift us naturally to smaller scale systems in a more distributed pattern. So this vision requires a host of innovations, and the NAWI team for the last 2 years, maybe many of you on this phone call, have participated in very extensive road mapping programs with us to outline where the needs are. And we've outlined them into 6 kind of key research challenge areas. The first in our A prime acronym stands for autonomous operation. If we're going to have smaller scale systems they need to be much more able to operate and run on their own. So we need innovations in sensors, adaptive process control, etc. The P stands for precision separations. If you're gathering in wastewater from all different sources, you have sort of a uniform chemistry. But when you are starting to treat or reuse very specific waste streams, you may want to extract only a subset of components. There might be only a single problematic constituent that makes the water unusable that you could potentially precisely remove and reuse that water. The R stands for resilient. If we're going to have smaller scale distributed systems, these things have to be rugged. They have to be able to turn on and turn off. They have to be able to accept wider ranges in water flow and water chemistry. And that resilience is one of the key factors that we think is going to enable small scale systems. The I stands for intensified. As many of you know, desalination systems produce fresh water on one side and a more concentrated brine on the other side. Disposing of that brine is a critical problem, especially when you don't have an ocean next door to conveniently mix that water in. Intensified brine management is the frontier of research on minimum liquid discharge and even zero liquid discharge technologies that would enable you to compress that brine waste and extract as much water as possible and make it as small and cost efficient to finally deal with those waste solids. M stands for modular. We do believe that if you have smaller scale systems, more distributed in a community, that these systems are going to have to be manufactured, which means you're going to have very tight unit processes. We're no longer going to be able to design and build each system by hand. We're going to have to think about building water treatment appliances. And then finally, the E stands for electrified. As you know, with the growth of renewable energy sources across the United States, clean electricity is available to us in our water treatment systems. Electricity is nice for two reasons. One is it can come from no carbon sources or even negative carbon sources. The second advantage is that if treatment systems only need electricity, it's very easy to hook them up, and you don't need to supply constantly new chemicals and sort of fill up totes because of the chemical supply. So one of the areas of research that we're interested in is exploring electrified treatment processes. Technologies, for example, like electrocoagulation instead of chemical coagulation. Okay, you can learn about all these innovation areas and our research program on our NAWI Alliance website and in our roadmap documents. But here's the big picture. If we can innovate in each of those 6 challenge areas and reduce the treatment cost, we can then enable small scale localized reuse, and we can escape the cost associated with moving water around. And that's how we think we can get to small scale systems that are cost efficient as appliances. Now, I told you that NAWI has been developing some tools, and I want to show you a couple of them because these tools could be used. Their intended community is you, the innovation community. One tool, we originally called it Proteus Lib, but it's now part of the WaterTap software family, is essentially a modeling environment where you can pull from libraries of unit process models and put together a system model that predicts the performance of hypothetical water treatment systems. Think of it, for those of you who are familiar with Aspen, which is a chemical modeling tool for the chemical industry. Think of this as like a version of Aspen for water. This technology is available. We are building a library of unit process models. And in fact, one of the things we hope to do in this piloting exercise is have you all work with the team under Tim Bartholomew at the National Energy Technology Laboratory to build digital twins of your pilot. So that's one tool. Another companion tool called WaterTap is a techno-economic modeling tool. So on this side, you have unit process models and chemistry. On this side, you have kind of economics and performance efficiency. And we use these tools together to allow people to explore different configurations of treatment strategies to arrive at cost-optimized water. The third tool that we've developed is called Water Dams. This is a data management and repository. So this has all the indexing capabilities to allow people to post data sets, information in a place where it can be indexed by all the sort of normal indexing sort of protocols that are out there, and allow other people to find data and results that you produce. Now, I said that in the first year, we spent a lot of time on our NAWI road mapping, and we produced 5 water roadmaps, the PRIMA roadmaps, PRIMA roadmaps, and we had a master roadmap. You can find all these documents on our open website at www.nawihub.org. But the other thing we did is we tried to do baselines. We tried to go out and study what's the current frontier performance of quote unquote conventional desalination and water treatment systems. And we did a lot of great work, but most of the data we gathered was, of course, for large scale systems, because those are the ones that are most abundant. So one goal of our program, just before I go on, this is an example of one of our 5 PRIMA roadmaps. This is actually going to be coming out as a peer-reviewed publication very soon in the American Chemical Society's ES&T Engineering Journal. So this is an example, and you can see the team members who contributed to describing the current state of water treatment and reuse in the mining industry. And we have 4 others like this, and these will all be coming out in publication. But one of the goals of our piloting program is we need better baselines of the small-scale desalination systems that are currently used. So we need to have a better understanding of the current CapEx and OpEx and energy costs for small-scale desalination systems. What are the most common source water types these systems are used to treat today? What are the current end-use applications and water quality for these systems? What are the most typical treatment trains in use today? And what are the most important frontier innovations to drive down the levelized cost of water and drive up utilization of small-scale desalination? These are all key questions. And we're, as I said before, NAWI is particularly concerned about innovations in high concentrate water treatment. So brine concentrate or high saline waters are a particular challenge for our current technologies. And this is an area of innovation we're particularly interested in. Now, the other thing we're hoping to do with this pilot program is to advance the frontier of small-scale desalination and water reuse systems. So what are the most promising innovations in unit processes and system designs? What technologies, designs, and operations might lower the levelized cost, both capital and O&M cost, might improve the performance in terms of water recovery or lower energy use or improve water quality, might improve the robustness of systems, including adaptability and reliability, and improve the compatibility with different water types and different existing infrastructure, as well as the sustainability. Where can we find innovations that will allow us to produce better water at a lower cost and with lower energy? And perhaps most importantly, how do we address a persistent and enduring problem in the United States? And that is that particularly disadvantaged communities often have access to the worst quality water or no access to fresh water at all. How can we think of the innovations in desalination and small-scale reuse serving those communities and people from those communities? So why are we doing an RFI, which is a request for information? Why not just issue an RFP? Well, Zach and I need your help. That's why we're doing this. We need to think about how to design the boundaries of the RFP. We need to think about what scale system is going to be called for in the RFP, what range of technologies might be of interest, and what specifically to ask for in the concept paper and full proposal. So we also want to encourage novel collaborations and teaming. We have 120 people on the call today. Many of you have very interesting technologies and insights that the rest of the people on the call don't know about. So how can we get people to begin to network with each other and figure out how to build these systems? As you know, piloting in real world settings with real water is the acid test of any emerging treatment technology or treatment train. It introduces new constraints, it introduces important variables that simply aren't present in the laboratory. So our piloting program is going to be looking for pilots that are in real operating settings. Okay, so here's some general things the NAWI team has been considering. Again, I want to say this is an RFI. Nothing is certain yet. Zach and I are seeking advice from you. So we're wondering how much to fund each pilot team. We're thinking probably $500,000 from DOE, and we also have, some cost share partners. Now, if we get a sense that we should have more funding per project, then that would obviously translate into fewer pilots. I will note that our partners at California DWR and the water boards in California are also going to contribute additional cost share support to those projects that are either in California or are of interest to California DWR. So for those of you considering a pilot project, you may want to think specifically about how California problems or a California setting might be the right place for your pilot. How many pilots to fund? Well, I think we're sort of thinking about 4 to 6. We have, of course, a challenge in how many we can manage, but also we want to make sure we fund enough that we have a broad distribution of technology attempts. How big a demo? Again, we're going to ask you some questions in a moment about this, but half a gallon per minute average production, 1 gallon per minute average production, and a question of how long should a system be running to produce water. How to choose pilots. We think we're going to be doing a 2-stage RFP, first asking for concept paper, followed by full proposals, maybe a pitch session for finalists. And then one of the questions we've already gotten a lot from some of you is, what do you mean by innovation? You know, what sort of systems are you looking for? And we may talk more about this in our Q&A. What we mean by innovation is we do want to see pilot systems that contain at least one novel or new or enhanced process in another, and it could be in an otherwise conventional system. So for example, you could have a novel pre-treatment process in an otherwise conventional system. You could have a novel brine concentration and crystallization process, and the balance of system is relatively conventional. We would, of course, love to see multiple processes and multiple innovation elements, but we recognize the balance of risk in each time you introduce a new unit process. So that'll be one of the factors that we're weighing in choosing pilots is we do accept that there are going to be some compelling pilot opportunities that are going to be relatively high risk. And then there might be some other piloting opportunities that have a more balanced set of risks. And one of the questions we've received is, can teams compete if they already have existing hardware? If they already have a system that they built maybe for a previous research or a previous operation? The answer is absolutely. We think that's going to be allowed. But again, we don't want to see just a carbon copy of what was done before. We want to see a significant enhancement on top of what was already demonstrated. All of this, by the way, is subject to change. Our procurement experts at Lawrence Berkeley Lab stress that an RFI is just essentially marketing analysis. We're seeking to understand the market, we're seeking to understand your capabilities and your interest areas. And that's why we're having this call today, and that's why we are requesting this RFI. Okay, so Zach, I don't know if you wanted to come back on, but I know that we have set up some poll questions with Derek. And so the first poll question, what we'd like you all to do is we're going to put some polls up on the screen. And Zach, I don't know, before we do that, have you looked through the chat, and is there any question that you think we should address before we go into the polling?
I am fielding those questions furiously, Peter. So I think
you are good man. Good
stick with that right now. And I think Jen has the keys to the polling.
Good. Okay, so we need some advice from you all, and that is one poll question we have is about level of federal funding, and that is, what do you think the minimum federal funding amount you would need to be interested in, and potentially able to participate in a piloting program with these sort of constraints? The total period of the program is 1.5 to 2 years, obviously with some design, et cetera, and then some period of fielding and operation. We will almost certainly have 50% minimum cost share requirement for these projects. And so if you say that we need more funding, well, then there's going to be more cost share required as well, and fewer pilots. But the answers we have in this poll are listed here, but let's put up a poll. Jen and Derek, can you put up the first poll and see if we can get everybody to participate? So everybody, here's your first poll. And actually, we're going to go on to the second poll here. So we have all the poll questions here, and you can just scroll through. So the first one, what do you think is the minimum level of funding that you would need in this situation to participate in this program? Okay, you guys can answer that question. Question number 2, if you scroll down, is let's assume that the federal funding is $500K for pilots and that's a 50% required cost share. What size system in terms of clean water production would you consider trying to demonstrate? And your range of answers is from less than half a gallon per minute to this range all the way through up to, we think we could demonstrate a technology at greater than 5 gallons per minute treatment production. Question number 3 is, assuming 500K in federal funds, 50% required cost share, et cetera, what kind of non-traditional water source would you consider to treat? And I just listed a bunch that I could think of off the top of my head, and there's certainly a very large potential number of non-traditional water sources. So we're just curious what areas you think are most ripe for demonstration. If you were to submit a response to NAWI's RFP, would you need help with any of the following teaming or resources? And you can click as many of these as would apply for you. For example, you may want additional research partners or industry partners. Zach and I, by the way, are going to be talking to some of the NAWI Alliance members who produce, who are equipment providers, and see if some of them might actually be willing to provide free equipment for some parts of these things. Again, no promises yet. Zach and I have to put on our charm suits and go out and do that work. Question number 5 is our last question, and it's, we're considering hosting an online workshop in which you all would come. You could give pitches about your technology, and you could also potentially meet or scout other potential team members. How interested would you be in participating in this? And so that is our 5 sets of questions. So thank you very much. Zach, I don't know if you can see, or Derek, if you can see how people are doing, but we'll give you a few moments to still go through those questions. And we, again, all the advice you could give us would be super, super helpful. And I repeated those questions here in the slides. And one of the reasons is these slides will be available to you. And so, again, if other people missed today's workshop, you can get them this information. Okay, now I'm going to wrap up before we do our Q&A with a possible structure of the RFP. And again, I want to say this is all, up in the air. We may not have an RFP if we can't figure it all out, but this is the sort of things that we're thinking about. So we are thinking about a concept paper process first. We would then review and down select projects that are best aligned to the NAWI program. So I want to emphasize that we are aware of all the extraordinary work that many of you are doing. And some of it might be great work and be a very promising pilot, but might be a little bit more peripheral to NAWI's key research goals. So it's no judging. This is not the Westminster dog show. Many of you have great stuff. There's a subset that's very relevant to us. We would then have a subset of those concept paper submitters request a full proposal from them, maybe plus or minus a pitch. One of the things we would definitely like to see in the full proposal is clear teaming relationships and an IP management plan. Again, we would have more information about what that would look like, but one of the key areas of concern, obviously, is when you do build a pilot, you are also developing your own IP, and we want to make sure that we can guard that as carefully as possible and allow you to maximize the benefit for your business or for your activity. So we need to think carefully about how to make sure that the pilot is working for you and gives you the protection that you need. If your team joins the piloting program, your organizations will sign the NAWI Research Consortium Agreement. It is a long document, but it governs everything from how we handle NDAs to a US manufacturing agreement. You can see a copy of this NAWI Research Consortium Agreement now. It's available on our open website. You can download it and look through it. I know 82 pages sounds like super intimidating, but look, we spent a lot of time with the DOE and a lot of our partners to craft that agreement. We already have 60 consortium members, including a number of private sector companies. So it's not an impossible document. We know people have executed this consortium agreement already, but we definitely wanted you to be aware that that consortium agreement would be a requirement for participation in this program. Okay, once we selected our projects for negotiation, we would then potentially get projects started in Q1 of 2023. So this whole arc is about a year of journey to get these projects started. And then Zach, you and I have been talking about having projects run, a period of design followed by a period of build and a period of operation. So maybe 18 months or 2 years. We haven't quite decided there. All right, so that is the end of my prepared remarks. And I, again, want to encourage you to do 2 things. Go to nawihub.org. If you are not already a member of the NAWI Alliance, click on the join button and you'll get a application, and then you can join the Alliance, and we'll get a login for the NAWI Alliance website, and that gives you access to all our recordings, all our information, etc. And with that, Zach, is there anything, like in terms of stuff you've referred to before we open up the floor to open questions, is there anything that you think people would like to hear from the questions that you've seen so far?
I think we have a couple of good questions. Megan Plumley was asking, if we even want to consider putting a minimum flow on some of these requirements, and maybe this is an area for Q&A, but I think that it can go both ways, right? It's like you don't have necessarily review criteria, and somebody could submit something that's a lab scale, but at the same time, you might be excluding technologies. So I think this is a difficult and kind of a sticking point.
Well, I was thinking of another reason why it's difficult is that in absolute flow, so much depends on the non-traditional water sources you're using, right? If you were treating municipal wastewater, the desalting step it could be relatively minimal, and the few other things you could do could be pretty gentle. If you're treating concentrated, highly saline produced water, your energy associated with producing the same volume of water is much, much higher. So we'll give that some thought when we think about the criteria for what flows are going to be required. And I think that for us, operating in a realistic environment is probably the most important challenge. But again, we will define all that at the RFP level. But it's a great question, and thanks for that. Zach, what other questions do you think people would be interested in?
I think
hey, we have the poll results. Awesome. All right, everybody. Well, this is great. And the reason we did this polling is that we also wanted you to see this, to see what people are at. And I don't know, Derek, if you have a number of respondents for this, but you can see here that people are pretty comfortable across the board with the flow rates. And it looks like we have a pretty good distribution of non-traditional water sources that people are interested in. And it looks like a lot of people would love some help on teaming and resource allocation, and that's great. About a third would be interested in labor for running and monitoring the pilot. Zach, one of the things that you and I have talked about is that there are across the United States facilities, water treatment facilities that have a demo site or a demo area. So for example, the K. Bailey Hutchison desal facility in El Paso has a nice, beautiful laboratory with side streams from various steps in their process. So you can actually take water and then do a side stream application, et cetera. And those demos would certainly potentially be of interest. And then finally, question number 5, an online workshop. Sounds like everybody's game. Zach, that's terrific. I think that they've thrown down the gauntlet. They want a workshop, and we'll put that together for you guys. But I think that's great. Thank you guys so much for all your input. This is exactly what we need. Zach, what other questions do you see coming in the door?
Maybe not some questions, but at the very beginning of the chat, if people haven't stuck their head in there yet, Zahi and Rodney and other individuals, Melinda, people were posting information about either their technology or their test site, just because they know that the chat is going to be logged and posted publicly. So if you have information you want the participants of the workshop to see later, feel free to throw that in the chat and it'll be recorded.
Thank you, Zach. And getting back, maybe you and I can sort of continue to dialogue a little bit while people consider the chat and respond in the chat. But Zach, another thing I have gotten questions about is there are some really exciting, fully commercialized desalination systems out there, and a fully commercialized system with essentially, presenting for a pilot something that's already commercially available is probably not the level of technology innovation that would be supported under this program. However, if you have a conventional system and there is a specific novel element or set of elements, that, especially those that dramatically improve the performance of the system relative to those criteria I showed before, right? So I showed you earlier, like innovations to help us lower the cost and lower the energy associated with this. So I'll go back to these criteria up here. so you all can remember. When we consider innovation, it's not just, sort of cost itself. You could imagine that cost could come from lower capital costs, but also improved revenues. So one of the ways that you can improve the cost of producing water is that your waste stream, instead of costing you money, might actually make you money. So there were some really interesting ways that people are exploring upcycling of brines and converting them to valuable constituents. Of course, in small scale systems, performance remains a critical issue. These systems have to be rugged and reliable. You're not going to have a licensed operator sitting around all day and all night monitoring a system. So these systems need to, to be very simple and remotely monitored. And also a lot of cost and risk comes into unit processes that involve, caustic chemicals. So everywhere where you can lower the profile of occupational health and safety risk associated with treating water is also a performance improvement. Robustness, we talked about, Zach, that the ability for small scale systems to be turned on and turned off, that every time you turn it off, you don't have to, or turn it on, you don't have to tune it up very delicately. That sort of robustness is a key attribute we think that's going to be important in small scale systems, as well as compatibility with different water types. And boy, this frontier, some of you know, the frontier of regulations for small scale reuse systems. This is absolutely a frontier right now in the regulatory world. And there are many states whose regulatory framework on water reuse is still very incomplete. We recognize that. So we know that in some places we're thinking about water systems that the regulators still haven't even conceived of. By the way, and I know many of you work with regulators often, but in these pilots, it might make sense for you to draw in, wherever the pilot is, to draw in and alert the state regulators so that they learn as well. Because I think the regulators are eager to see water reuse gain acceptance across the United States, but the regulators are often sometimes the last people to know. So this might be one area for you to consider reaching out to them early and actually maybe even engaging them as a team partner. And then also sustainability. In California, for many of you know that our water use is for many things, including human applications like agricultural or human use or industrial use, but also the environmental services that water supplies for fisheries and watersheds and habitats. And so the way in which we could reuse water, allowing more natural water sources to be used for those environmental services, is one thing that I think you should always consider. And again, I emphasize this. NAWI, from the beginning, we've recognized that historically, water treatment systems have sometimes been invented and plopped down in a community with very little kind of introduction or harmonization with a community and its values. And that puts risk that sometimes even a very well-designed system may not get the maintenance and utilization that's necessary for its long-term upkeep and success. And so one of the areas that we hope that we're going to explicitly identify is how your team and your project is explicitly addressing accessibility, diversity, equity, and inclusion goals. And one great way of doing that is engaging a local community organization or community leaders as you're even planning the design of the pilot, so that they can be present and understand the technology, understand where it's coming from, and can help you achieve greatest acceptance of that technology in the real world. So those are some key things when I think about innovation that we hope you guys can think about. Zach, what other questions are coming in that you want to have us all talk about? I'm going to stop presenting my slides, and we can continue this conversation with everybody.
Yeah, I think there's just more good. There's more good discussion surrounding, what is a good minimum pilot, or do you even want to put a number on that? And so Megan, I'd asked her to kind of chime in a little bit more and elaborate on some of her thoughts. And then Chris has kind of been chiming in. Just regards to, Megan had said she's thinking of a pilot that could primarily mean that it has quote unquote graduated from a bench scale and is being tested in a realistic environment. So I don't know if I want to necessarily read all this or if we want to open it up.
Well, you know what, maybe why don't you call it, if Megan Plumley, we can unmute Megan Plumley, I think we can, and we can have individuals. I know you've written your questions in the chat, but it's also nice to be able to present them to all of us. So can we find Megan on one of our screens and see if she's able to speak to us directly? It's hard with so many people. This is exciting.
I see her. I don't know. Let's see. Megan, are you available to chat?
Did you find her?
I did. I do not have the unmute wand though.
I wonder if Derek does. Derek, can you unmute, or is it?
I can't unmute her, but I can give her permission to unmute, and I've tried. I don't know if she's available.
Okay. People can raise their hands if they want to speak. At least I can raise my hand. See that little reaction button down there? You can raise your hand if you want to speak. So if anybody wants to make an additional comment, give us advice, you're welcome to. I see lots of friends out there. So hey, Rod Harrington, are you in Albuquerque? Where are you, buddy? Albuquerque? Nice. Nice. There's Pedro. Yes, in his office in Rice. Good to see you.
Peter, we've gotten the question about partnering a couple of times. What do you envision the partnering requirements to be, or is it going to be more of an encouraged if we release an RFP?
I don't, in our RFPs for research projects so far, we have encouraged partners, but we have not made it an explicit thing. We do look at partnerships as a resource, part of when we score projects for resources. And when we see a project team that we recognize has lots of complementary capabilities and seems very well anchored in terms of talent and breadth of talent, that tends to score higher. However, we have funded projects with single researchers. So again, we try not to be prescriptive, but we do recognize that teams sometimes bring forward multiple talents. The other thing is, in a piloting program with 50% cost share, it's almost certain that you're going to have additional partners who, if nothing else, will be providing equipment, loaning you stuff, or providing resources. So those are also places when we look at projects and look at the resource side of things, partners are one of those resources we consider. What other questions?
There are questions all across the board, Peter. Do we think that we should open it up to the Q&A right now more formally, or do you want to just keep going through the list here?
I think if people are looking through that, I can see everybody furiously scanning up and down on the chat. But I know that there's some general comments, maybe general pieces of advice people have for us. And so I would say I'm happy to open it up for direct questions. So what I would suggest is you can raise your hand with the reaction button here. You can raise your hand. We will call on you, and then Derek can give you permission to unmute, and then we can hear your voice. So I see Rodney's raised his hand. Good man. Always count on you. So can we unmute Rodney and then hear what Rodney has to say? Rodney, I think you're on.
All right, thank you. So Aqua Membranes is the printed spacer technology we developed. But this whole printed spacer technology came out of a DARPA program for the government a few years ago to develop a system that could treat any water anywhere to US EPA drinking water requirements. And it was a handheld, it was a small unit, a small system. So we originally did spacer technology, maximize the amount of permeate that could be produced in the system. So, that system was never realized yet. We have a lot of innovations in it. And when you say small scale, I'm talking about scale of point of use.
Sure.
It's your picture there with the water bottles on the front porch. Is this thing open to really small systems? I mean, you're talking less than 0.5 gallons a minute. This is less than 0.5 gallons a minute type systems. We've got a lot of innovations in that can be applied, and it's got universal worldwide application. lots of different, worldwide.
Yeah, so Rodney, it's a great question. I'd also say you bring up a very important partner that we haven't talked about explicitly, and that's the Department of Defense. Department of Defense has over the years had a number of research programs in the area of water treatment. In fact, they have a current program I think a couple of you may be engaged in, where they are trying to generate water at the scale of the individual warfighter, as well as at the scale of a squad. And the DoD has always been concerned about that remote literal point of use, point of the spear tip water generation. Rodney, I think that in an RFI, we're interested in hearing those ideas. And if we see a breadth of people who say, hey, this is an important frontier, we want to explore it. And the only other thing I'd say, Rodney, is that as we think about water supplies, we also think about volumes, because feeding an individual for some period of time is a very high value application for the Department of Defense and for the warfighter. When we think about fixed communities, the question is, do those technologies scale up to the point where you would have fixed supplies for people who have houses, as opposed to a squad of Marines running around in Afghanistan? But no, thank you for bringing that frontier out. It's something we're aware of. Thank you very much, Rodney. And when you're done, you can actually click your hand down, so you can put your hand down. Arian's there. Hey, buddy.
Hey, how you doing?
What question do you have, Arian?
Well, we've done a lot of these smaller scale pilots. There's a lot of data that I'm happy to share with you guys as you're developing this RFI process. Feel free to reach out. The question that I have is, by doing so, do we get excluded from actually participating in it?
I think we would always be careful. And again, I don't want to speak because I'm not the procurement experts at Lawrenceburg Lab. Whatever we did in seeking information, we would do so in a way not to skunk anybody's eligibility for actually participating.
Right. Okay, good.
So we'll be careful. Whatever we do, we'll make sure that we don't skunk your opportunity to play.
Perfect. So feel free to reach out, and we'll
super.
We can have a discussion.
Thank you very much. Oh, we have Dr. Peters from Europe. Dr. Peters, your hand is raised. Can you hear us?
Yeah, I can hear you. I hope you hear me.
Yes, sounds good. Where are you today?
Because I am in Mallorca in Spain.
Mallorca. Okay, now you get a lot less sympathy from the rest of us.
No, it's an office. It's my office. I work here. Yeah. But no, the question, Peter, is really all what you're doing is a great job. Really, what you're doing for the humidity, I think it's very, very interesting. But we feel a little bit that is missing the possibility to discuss about the seawater intake. You know, my special favor.
Yeah.
Mostly the seawater intake is the most important point in membrane technology. And there, as you know, we have some preferred stuff. We will discuss this next week in Filtech in Cologne in the conference, where, by the way, I cite you also with your Navy program, by the way. Mm-hmm. I think, and that's the problem I have as I'm an independent consultant, so how I can join forces with other people to bring ahead new ideas. That's a problem from Europe.
Well, so for Dr. Peters, for starters, seawater intakes, as you know, can be absolutely the hardest part of a RO, an ocean RO project. They can easily consume a significant amount of the total project time just getting them permitted. And if you don't believe me, come to California and try to do it. But I would say also, innovations in intakes that address the environmental constraints that states like California have, while at the same time have engineering practicalities associated with them so that they're easy to deploy and easy to maintain. All I could say is we would love to hear in the RFI process interest in that area. I will say that there are some great people in the United States, some of whom you know, California Desal Association, Cal Desal, just had their winter meeting last week, and intake screens were one of the topics of innovation that were considered. So again, the RFI, it's interesting to bring that forward. So we'd definitely like to learn more about it.
So I will send you something to clarify, because as I know, in California especially, there's a lot of wrong information about this new system that I talk about. And I don't know why it came up, but I will send you some info, and then you should have a look on this one, because I think it's very important that we see what's happening on the world.
Perfect.
And not because of wrong information and false information, by the way, published by even publications. Wrong. And that's really where I, as expert, may say, stop, boys, that's not the correct way.
Yeah.
I will show you that there's better ways to do it. But thank you for your words. I will send it to you, and then we can discuss it. Keep in touch.
Again, for everybody on this call, once you join the NAWI Alliance, you have access to the entire Alliance community. You can email and get contact information for everybody else. You can find these other people who are out there. Yeah. Gilbert Vandeventer, where are you today?
I'm in Odessa, Texas, West Texas.
Nice. What's your question?
We have oceans of brackish water.
Yeah, I know you do. I know you do.
Some of them are, major aquifers, and we have a lot of produced water that's generated, and we need to clean it up for beneficial uses, whatever that may be. We have a system. We have a couple of systems actually that we're just dying to put out and share with everybody. We're using ceramic filtration and electrodialysis reversal and nanodiffusion. And I know that's not the purpose of this meeting to get into that. But my question is this, Peter: is it important or encouraged, recommended that we partner with a national laboratory on this effort? We've got a lot of available partners already. University of Texas Permian Basin is one, and then the manufacturers of this equipment. But we are looking for say an end user that needs the clean water, but all the while we want to better the system. So
thank you, Gil. So
again, I'm sorry, the question.
Yeah, the question of whether it's helpful or important to have national lab partners. I would say when we look at projects, and we've done this already with our research projects, when we see a national lab as part of the team, we do look very carefully to see what are they bringing to the table, what key critical competence or critical capability is represented in the team. That's how we judge things. So we don't say, you got to have a national lab member no matter what they're doing. We want to see that synergy. I would also say, everybody on this call, in addition to NAWI funding, many national labs have these key capabilities: advanced light sources, high performance computing capabilities, and they have their own funding calls that provide all the funding for research. So if there's nothing else, Gil, to familiarize yourself with the capabilities of the national labs, so that well, next time I want to know exactly where this metal ion is sitting in a polymer at very diffuse levels, I might consider partnering with Brookhaven or Lawrence Berkeley Lab or Argonne National Lab to do that investigation. So that's a great place of the win-win that comes from the key capabilities of the national lab. So thank you for the question, Gil. Anybody else is welcome to raise their hand and provide a question to all of us. We still have time today. Zach, I see you're still fielding chat questions. So if there are any that sound particularly saucy, you're welcome to bring them up to everybody's consideration.
I think we're doing a pretty good job fielding the questions within the chat. So maybe people can take time to look at that. I think, Gilbert, we had stuck a suggestion there. One thing I don't know if we're able to put Christabel on the spot, but I know she's got, WRF has the TechLink program. And I don't know if there was desire to talk about that, Peter, or talk about other resources to connect people and do some of this matchmaking.
Well, TechLink is a great resource. So for those of you who don't know about it, or of current technologies that one might consider. And it's funny, Dr. Peters from Europe is on the call. I just was attending the Waterloo Filtration Institute annual meeting, and I learned about a filter media, a glass filter media, glass particles that have surface functionalization, and looks pretty good. So even for those of you who are experts, you can always stumble across new stuff. And a small package, high efficiency, media filter could be a perfect pre-treatment piece in somebody's system. So that's what we're trying to do here is make sure people get the opportunity to learn about new things. I see Marcus Griswold from CSIRO is raising their hand. Marcus, we can unmute Marcus. And where are you today? Are you in Australia or are you here in the US?
I'm in our US office in the San Francisco Bay. Hi, Peter.
Good.
Nice to meet you.
Good to see you.
I just wanted to clarify the chat. We asked about federal cost share, and it sounds like that's a no-go. But just wanted to check if if we're working with a facility that's federally owned and operated, if any of their in-kind cost share would be allowable.
And no, unfortunately, DOE has fairly high bars on this. Any other funding or resource that is federally supported cannot be counted as cost share. It certainly can be used. It just can't count towards your 50% threshold of cost share. So that's their rules. They're pretty specific about it.
Well, thanks for sharing.
You bet. What other questions are out there? Still see we got a lot of people on the line. A lot of people think. Any advice? Milka Montes?
Yes, hi,
hey.
Good morning.
Where are you today?
I'm doing well, thank you. I'm at the University of Texas Permian Basin in Odessa.
Yeah.
I'm in collaboration with Gilbert and the Venture. We have, it's just, my question is, how big or how small would this collaboration be advisable? And also I was thinking, because I have experience with national laboratories, is it recommended to have a national laboratory partnership in case that we have this developing into an actual proposal? Any suggestions that you can give us? We're kind of started here.
It's a great question. And actually, Milka, you've given me an opportunity to maybe preview some of the sort of, I want to say, challenges. But doing business with the federal government, for those of you who haven't done it before, does take some care and early strategy. For example, if you have partners who are simply contributing material or contributing something, but not actually participating in the intellectual development or the intellectual property creation, that's a much simpler relationship and doesn't require as much contracting oversight from us. So for example, if UT Permian Basin got a bunch of sensors from Hawk, and Hawk just donated the sensors and their retail cost would count as cost share, and Hawk wouldn't be under any contract with you, so it's very simple. In contrast, if Hawk said, well, Milka, we want to give you this new sensor technology we're working on, but we also want to develop the technology with you, and we want to reserve some IP rights associated with working with you on that technology, we would then need to create what's called a Cooperative Research and Development Agreement, or CRADA, between Hawk and Lawrence Berkeley Lab and UTEP and Lawrence Berkeley Lab, or not UTEP, but Permian Basin. And so how you define your partners can make things involve more contracting or less contracting. Now, Zach and I will have resources for people when we release the RFP, including some videos that explain how to parse that so that you can try to do it a little neater. What we don't want to see is people mistakenly piling on a bunch of partners and commingling a bunch of IP in a way that makes it very complicated for us to define the contract. So we'll give you advice about how to tidy up the partnership. So it's perfectly reasonable, Milka, to have several partners who will be receiving federal funds, and that those partners will be working together on the research and will potentially develop a cooperative research and development agreement with them. And so it's fine to have more than multiple partners. The issue is, are partners just contributing supplies, or are they actually participating in the innovation? Okay. That's some of the key decisions about how to parse the partners into one or two things. And then your final question about national labs. Look, national labs are great resources, and they have, in some cases, world-class and unbeatable resources. So it's up to you. But we're not gonna ding people if they don't have a national lab, or we're not going to give people extra brownie points just because they have a national lab. We're going to look at the resources on the team, the breadth of the resources, and how the team is contributing as a whole, and that'll be one of the scoring criteria for the pilots.
Excellent. Thank you so much.
Thank you. What other questions are out there? Yes.
We got a really good one from Marcus. And he asked, could you clarify that we need to respond to the RFI in order to respond to the potential RFP?
there is no requirement for you to respond to RFI. However, Zach and I would love it so much. We'd be so sad if you have all this great advice and you don't share it with us. So I can say there is absolutely no obligation for you to respond to the RFI, but there are two values. One is the more feedback you can give us, the better a program we can design. And secondly, if I get like 100 RFI responses, that tells DOE that this is an important subject. Maybe we should receive more funding for these sorts of things. So we are a community, right? This is your hub, right? This is for all of us. And the degree to which you engage helps me, make water treatment a priority for the Department of Energy. And so that's my request to you, is that RFI responses help me in those two ways. So thank you for the question, Zach.
And I'll just add one more thing on there if I can, Peter. We realize everyone's time is really valuable, so RFI is actually pretty quick. It's not going to be a really belabored process. And so, yeah, it shouldn't take you too much time. We filled out mock examples, and I think we're somewhere around an hour, maybe an hour and a half. So just a very ballpark number. If you're thinking it's going to take you multiple days to put something together, I don't think it's that involved. But the information we're asking for is really going to help us craft that RFP.
Yeah, and even if the information is, boy, you guys should talk to so-and-so before you design your RFP, I'm fine to get that advice too. Dr. Peters has his hand up again. Dr. Peters?
Yeah, Peter, one question. I try to be member of NAWI, but it's not possible because I'm in Germany or in Spain. So NAWI needs national, so it means to be only focused on United States. Is this correct? Because we have no contact by the email. They don't. They threw me out.
For starters,
Yeah.
Dr. Peters, let me apologize, because international partners are welcome in the NAWI Alliance. The application, however, needs to be reviewed by the Department of Energy, and sometimes, even for something as simple as that, it can take some time. So I apologize if you submitted your application to the Alliance but have not received word.
Okay.
That is simply because the digestive tract in the Department of Energy is long. And foreign, non-US bites tend to need more digestion.
I will wait. I will wait. Thank
good.
you. Yeah.
Good.
Okay.
I see Nacho there. Hey, buddy. Where are you? Hold on. Let's Ignacio.
There we are. Yeah.
Yeah.
I'm in California.
Oh, very good.
California. Yeah. Back in California, here in close to Carlsbad.
What's your question?
All good. So my question is, apologize if you already answered this because I had to drop out from the meeting before. Are you only interested in this RFI for research or piloting programs that happen in the US, or you are also interested in what is going on overseas? So is this a requirement to have to mention the pilots and the research that is going on in the US only?
So I would say, for starters, no, at the RFI stage, Nacho, we'd love to hear about anyone internationally, especially because also it helps me if there are a bunch of you who say, hey, there's some stuff going on, in Spain, we've got, Life Dreamer, which was, a successful thing. That helps me because it builds our database. And I will say, though, speaking quite candidly, the U.S. Department of Energy needs a lot more reason to flow funds to foreign participants in foreign countries. Okay, so that it can be done, but it often requires a much higher threshold of justification. And so that is simply just a fact of life that US dollars tend to like to stay in the United States. However, if there was a version of, a Life Dreamer project going on in Corpus Christi or Tampa or somewhere, then the fact that even though Acciona is an international company, the fact that it's happening in the United States would definitely make the funding of that easier.
Sounds great. Yeah.
Good.
Thank you very much. Really good job, Peter.
Thank you very much, Nacho. Good to see you.
Good to see you.
Any other questions? Arian always has questions. He's a very questioning guy.
I actually do have a question. If you
See, I told you.
So I was reviewing the template. So this template, the RFI template, seems to be more like a concept paper, right?
No, don't say that. It's an RFI.
No.
Yeah. We're just looking in for advice. We're looking for people to say, hey, you know, if this came around, this would sort of be one of the kind of things that we'd be interested in. But again, we're doing market research at this point, Ariane. A concept paper, when we issue the RFP, the concept paper may repeat some of the same items. It may also ask for additional information beyond what's present in the RFI. But that is the intent of the RFI. It is market analysis and essentially seeking advice and a canvas from you, the innovation community in water.
So nothing specific, more generic information about what is interesting, what needs to be, what we think, what the respondent thinks it's, you know.
I mean, people can respond to the RFI with a very specific concept in mind, and that would be helpful. You can also simply tell us, boy, I have no idea how you do this, but you should figure out how to, you know, reuse this sort of water. That'd be fine.
Understood.
Yeah.
Okay.
Thank you for the question. Yeah.
Thank you.
Dr. Peters, is your hand still up or is it just left standing? Which is understandable. It's late in the afternoon for you. I know that hands can get stuck.
Sorry, I'm still up, yes, but I may only say thank you very much. It's a great job you are doing in your team. And I think for the future, it's very important to think about water. It's very clear. Everybody talks now, whereas 10 years ago, nobody wanted to talk about.
Yeah. Well, Dr. Peters,
very clear.
Thank you so much. Thank you for those good, kind words from Europe. And also, I would say that water in the United States, water treatment research, all the people on this call often spend years trying to squeeze research, you know, resources to advance the field. And I'm hopeful that the size of community we have on today's call and the size of the RFI response will be a very compelling signal to the Department of Energy that water is an important thing for us to be investing in, and we have a strong community of innovators who are ready to make the most of research dollars that are invested in them. So thank you again for those comments, Dr. Peters. Mr. Dole, I was wondering when you were going to show up.
How you doing?
I'm all right.
Good, good. Just a general thought on the flow rate. If especially some of the stuff that we're dealing with for the pitch to pilot, if we do a lower flow rate, I think that if we had a more of a automated, continuous instead of a batch process, be at a lower flow rate, would that weigh any more in a decision for NAWI versus, you know?
I don't know.
Because
yeah, go ahead.
That's some of the challenges we had with just the funding portion of it is we couldn't run an automated system. It was a batch system for this, and we felt like we would get a lot deeper knowledge of what the system could potentially do if we ran it as a continuous process, even be it at a 1.5 GPM flow rate.
Eric, you raise a good point, and that is that, you know, something as innocent as saying something needs to run for 3 weeks suddenly could necessitate a set of additional costs and a set of additional engineering burdens that would be burdens but not terribly informative. Like, for example, you might require larger tanks, and then like, I can't put a 5,000 gallon tank on this parking lot because the people who own the parking lot don't want the asphalt smushed or something like that. So I recognize that there might be some trade-offs associated with production levels and production rates. Again, the RFI is designed to canvas. And if that's some of the feedback we receive in the RFI, then that might be adjust our thinking for how we define the RFP. But thank you for bringing it up. It's a very valuable point. Tanks, I don't know, the people who buy, you know, the plastic 500 gallon, 1,000 gallon tanks, they're what, about $1 a gallon of, you know, storage, and they're a pain. So, you know, I recognize that storage can be an annoying thing.
Thank you.
You bet. What other questions? Zach, do you have any other hot questions you want to elevate for us?
Yeah, I hadn't responded in the chat, but maybe you can give some more color on this one, Peter. Someone had asked, are we equally interested in desalination and water reuse, or does one have more weighting than the other?
I would say that we do not have we don't have explicit weighting of one versus the other. When we have treatment that essentially that is not related to desalting. So, for example, people have asked us, like, what about just piloting a PFAS technology? And the answer is, NAWI is a desalting hub, and there are times and places where PFAS ends up being a really problematic constituent, for example, in the concentrate. And then you are sit there left with the challenge of how do I get rid of this PFAS, and it's commingled with a bunch of brine. That is an example where a PFAS technology is working in synergy with a desalting technology. I would also say that in the world of precision separations, there are plenty of environments where a problematic constituent, a metal, for example, is present, and that is holding you back from essentially reusing water. I think that qualifies, even though it's not a monovalent salt, it definitely is a solute. Again, this RFI is about seeking, what is the breadth and the boundary? When in the RFP, Zach and I may end up restricting things or giving advice as to what's in the centroid of the curve and what's on the wings of the curve. But mostly what we're here to do is learn. So that if you had a question and you say, hey, I've got a great technology, but it's not a desalting, it's a treatment technology, we would, of course, want to learn about that. Eric, is your hand up again? All right, well, let's go on. Eric, is your hand still up? Or your hand is still
okay,
up?
there you go.
are,
Yeah. So, I wouldn't be doing my job with the multi-state salinity coalition if I didn't say, when you mentioned PFAS, there's a whole track on PFAS at the MSSC next week in Vegas. So
thank you very much for bringing that up. That's a very good point, Eric.
Yeah, so that'd be, if those of you that are interested, just get on the internet, look up multi-state salinity coalition. There's a agenda.
Is that happening in person or is that virtual next week?
It is in person.
Goodness gracious, that's gonna
same week as AMTA, so that should be fun.
Yeah,
at the same place.
Very good. Okay,
Thank
very
you.
good. Thank you very much for bringing that to our attention.
Peter, TJ asked a great question. On the poll, it mentioned that the pilot duration was around 1 to 2 years. So is this the length that we anticipate the entire project to run, or just the testing phase?
I would say the entire project. So Zach, you and I have been talking about it. We assume there's going to be a period of design, a period of build, a period of fielding and startup and shakedown, and then some period of performance. So yeah, and again, we would also seek advice. Like if you say, it doesn't have to be 2 years, like we get it all done in 18 months. Zach, I mean, you used to be intimate with the pitch to pilot program. What was the total length of time from the time of contract signing? Kind of what was the average kind of amount of time that people spent working on those pilots?
Well, just like NAWI, it varies. Sometimes it would be a few months, and sometimes, I think when COVID hit and things got crazy, there were projects that took over a year. But I don't know. I think the 2 year-ish, 1.5 to 2 year time frame sounds about right. And if you can get a pilot that can run for 6 months continuously, right, incorporating the mobilization and commissioning and startup of something, plus the 6 months of continuous testing and kind of breakdown and analysis of results, we would learn a lot from that. I think you can get great baseline results in that amount of time.
Zach, did you ever hear the saying, have you ever taken a project management course, that there's schedule, scope, and budget, and you can have any 2 of the 3 you want? And so in this case, I'll tell you that, from the standpoint of this program, if you think about that principle, you've got schedule, scope, and budget. Well, the budget is fixed, for at least from the federal side. The scope will be somewhat fixed by what you decide and define to do. And so thus the schedule, that maybe one of the reasons why to let our program run 2 years is it gives people a little bit more envelope to take more time to gather more partners or to get an additional support from some other new location, that sort of thing. Schedule, scope, and budget. You get any 2 of the 3 you want. We're at our last 10 minutes. We still see 86 people on the phone. I guess people are wondering if some super sneaky tidbit of info is going to drop in the last few minutes. But no, we try to be all transparent. And now we try to keep it on the up and up. And also remember, we're here to serve you. This is your hub, right? Zach and I are here to help us as a community advance water treatment technology. So the advice you give us is sincerely sought, and we'll try to do the best with it. We also, of course, deal with our own constraints because we're dealing with the federal government. And for those projects that are in California or of interest to California, we will also be dealing with funding from a state partner as well. So that can get a little complicated, but we'll try to figure it out, make it as easy for you all, you performers, as you possibly can make it. Zach, any other final questions? I don't have anything. I could ad lib till the day is done, but I'm sure people have better things to do than listen to me. So any other final questions, Zach?
Nothing in the chat, but I did want to bring up, and maybe Jen can come on for this, Jen Berry at NREL. You know, we realize that there's probably a lot of questions that people didn't get to ask or didn't get answered during this workshop. And so on our NAWI Alliance website in HiveRight, we set up a very special spot for kind of a group discussion where we can continue this workshop conversation if people so choose. In our HiveRight site, you need to be an Alliance member. So Jen has put something in the chat of, please consider joining the Alliance. But once you become an Alliance member, you're able to get in there. And it's, Jen, what do we call it? It's the LinkedIn for water nerds.
LinkedIn for water nerds. That's right.
Yeah, I'll just show, for those of you who don't know this, I'm just going to share my screen and show you this wonderful site. So this is the hosting program is called HiveRight, but basically it's Alliance. You got to have a password to get in. But this has a list of all our users, so all the members of the NAWI Alliance, contact information for them, and people who have been active today. You can get to all our publications here. Our media center contains all of our recordings of webinars. So Jen, this is where we're going to post our webinars. So we'll post it in here along with all the other recordings that we have done. Yeah.
One point of clarification though, sorry on that. The recording
please.
is also going to be available on the NAWI.org site. So for those of you that are not Alliance members, not to be concerned, everybody will have access to that there, and Alliance members will also be able to access it from here.
Yeah. So Jennifer and Zach, were there any other particular areas or features in the Alliance site that you wanted to make sure people appreciated?
So there are three. So the People tab and the Organizations tab, you've already kind of gone through those. But for anybody that's interested, or if you're looking for partners, you have the opportunity to kind of distill and filter your results either by technology area or areas of interest and expertise. You can look by organization, you can look by geographic location. So it just gives you a lot of information and a lot of opportunities to network. You can actually send direct messages through the site to individuals. So if you find somebody with a certain set of requirements, or if you're missing something, you're welcome to go and reach out to them directly this way. And so that's really great. And then we also have a group that we've set up for the RFI in particular, so that if people would like to start having conversations and networking straight through there, you certainly can. It's just a really useful site, but again, it does not have to be used, or you don't have to be an Alliance member for the RFI to participate. It's just something that we're offering to people, and it's free to join. So
nice. Once you join, you can also see a lot of people have already populated their profile. It's very easy. You basically just, we have a single button that pulls your LinkedIn profile over so that you can populate your current profile with your LinkedIn profile. And then you can add additional search terms, etc. Okay, I'm going to stop sharing there. Everybody, thank you again for your time. Please consider responding to our RFI, giving us that wonderful insight that will help Zach and me design this program effectively to serve you. And again, Zach, any other closing remarks before we sign off for the day?
Nope, just the RFI responses are due on March 15th. And so if you can just navigate to that NAWI.info-ready website that I posted a couple times, you'll find all the information there on how to submit. You'll find the RFI response template there. So you hopefully made the instructions really easy, where you just submit your answers into there, and then you upload that document back into the info-ready site.
You bet. Okay. Everybody, with that, I will close us out. Thank you again so much. Be safe and stay healthy. And we look forward to getting all your advice in the coming weeks and months. And NAWI's Spring Alliance meeting will be announced shortly, sometime in May. And we hope we can see you all there as well. Remember, all of this is to you for the low, low price of free. All this is no cost to you. Thank you, everybody. Take care. Bye-bye.